Hello, I'm Mark Seymour from Future Facilities, Director responsible for our design and management software for data centres. I'm going to tell you how you can use Six Sigma Room Light to design or manage your data centre and avoid risk and hotspots. The first thing you need to do is to create the model of your room. So that means we need to look at the size and shape. You can simply drag the handles to make the correct overall size, and then with a few clicks we can sketch out where the walls go to get the complete room's shape. Once you've got your room shape, of course you need to put equipment into the data centre. And to make the most of the data centre, you need to get as much equipment in as possible. I'm sure you'll want to use typical design approaches. So we'll lay the equipment out in a hot and cold aisle approach. And what you have here are blue lines showing where the front of the equipment cabinets are, red lines showing where the back are, so where the hot aisle are going to be. The pink areas are showing the grills, bringing cold air from the cooling units into the cold aisle. Now, your data centre may not be rectangular, and equipment won't always be laid out in a perfect setup. We can simply remove cabinets that don't fit into the data centre and add them elsewhere where we can get a few more in. Once you've got the data centre looking just how you want it, of course you need to decide how much heat you're actually going to generate in the data centre. So what equipment are you going to put in there? In a conceptual design, you'll want to just work with a number of watts per square metre or watts per square foot or even watts per cabinet. It's quick and it's easy to change this. We simply set the value of kilowatts per cabinet and the heat will be dissipated in the cabinets by picking up a library and loading each cabinet with enough servers to generate that heat. So here you can see a cabinet, and we want to be able to get cold air to all those servers. So once we've got the equipment in, you need to be able to add your cooling system. Sizing the cooling units will be made to fit the equipment you've installed. From the library, you can pick out just the equipment you need. We're using a wizard here, part of the task guide in Six Sigma Room Light that will help you lay them out. You place the first cooling unit commonly at the end of the hot aisle so that it can gather in the hot air and blow the cold air out into the floor. Once you're happy with the cooling unit you've selected and you've placed it where you want it, you can simply duplicate it so that it can cool each row individually. The cooling units on the other side of the room, of course, will be facing the other way, so you can simply turn them round with the rotate handle and drag them into place. Once you're happy with your room layout, you can use the analysis tool to see what happens in your room. This is simulation using computational fluid dynamics to predict the airflow and heat transfer in the room. The screens that show while the simulation is running tell you what temperature the air is going in and out of the cooling unit so that we can see that they're cooling as we expect them to. Another screen shows you how hot the air is going into the equipment and how hot it is coming out, so we can see whether there's really a serious problem or whether the solution's looking good. We also like to know how well we're doing in the solution, so we have a graph which shows us how the errors are being diminished by the solver. Once this completes, the lines will reach the bottom of the graph. So once your simulation's complete, you can take a look at the model and see what's happening in your room. So what are we most interested in? Well, we'd like to know how hot the air is going into the equipment. Is it nice and cool as it comes from the cooling units, or has it got warmed by the hot air coming out from other equipment? As you can see in your model, the centre of the row has got some hot air going into the tops of the cabinets. So this is an area where we'd either redesign the room or we'd choose not to put equipment. Let's have a look and see why it's getting hot. We can plot the airflow from the grills. So you simply select the grill flow plot and it draws where the air goes in the room. And what you can see is cold air is coming up from your grills to most of the cabinets, but it simply doesn't make it to the top of the cabinets in the center of the row. Once we've identified the problem, we can use the simulation tool again, and you could try different techniques to avoid them. It's quick and easy to set up your model of your data center in Six Sigma Roomlight from Future Facilities, and now you can easily design or manage your facility.